1 mole of each of the following substances. There's CH3NH3Cl, CH3NH2 and HCl. And water was added to these flasks to give a total volume of 1 liter. So hydrogen chloride 1 liter, you'll have 1 mole in 1 liter, 1 molar HCl, and you'll have this will both dissolve in water. That's an amine, and this is what's called a quaternary ammonium salt. Right, that type of compound is called a quaternary ammonium salt. I'll explain why in a moment and what you can think that it looks like. Rank the solutions below in order of increasing pH. Now make sure you give it in the correct order. It's easy to do it all correctly, reason it out and give it in order of decreasing pH. They want it here in increasing pH. Justify your choice so you didn't just guess it, and include equations where appropriate. Now, right, with the HCl, quite easy. You add water, it's HCl aqueous, and there's H2O liquid there. What happens? The HCl gives away an H plus to produce H3O plus aqueous and Cl minus aqueous. And they want us to arrange them in order of increasing pH. We'll talk about the order in a moment, but this is quite straightforward. Okay, hydrogen chloride, add water. Why is it? What's going to happen? It'll dissociate fully. It's a strong acid, so it'll go to completion. Right? No equilibrium involved here. It's going to completion. Hydrogen chloride in aqueous solution, strong acid. Then let's look at what happens with this compound here, CH3NH3Cl. I'm going to draw something here to help explain it. Ammonium ion, a bit like this if you like, NHHH, NH4 plus, chloride, okay, ammonium ions and chloride ions. So there's the ammonium ion, because the lone electron pair connects to a H plus, and that will have a positive charge. You've done this in the other unit in your level 3 course. There's the ammonium ion, and that's with a Cl minus ion. Okay, that's the ammonium ion. Ammonium chloride, and there's the 2 ions there. Now, this particular compound here, which is our CH3NH3 1+, you can think of it as just being like an ammonium ion, except that instead of a hydrogen, all we do is we knock out the hydrogen and we replace it with a CH3 group, right there. So instead of just a hydrogen, one of those is a CH3 group. So you'll end up with what? CH3NH3 1+, Cl minus, right? So look at it over here, CH3NH3 1+, and then if it's the chloride, because that's what it was there, that will be an ionic salt, CH3NH3 1+ ions and Cl minus ions. Okay, now I'll look at this one first. This will react with water in a very similar corresponding way to how ammonium ions react with water. Ammonium ions, if that was ammonium ions was H2O, it will be an equilibrium, because ammonium ions are not a strong acid, they are a weak acid, okay? And therefore, this will do the same type of thing. Our ammonium, not ammonium, CH3NH3 1+, which is like an ammonium ion, reacts with water in an acid-base reaction, which is an equilibrium, in which this weak acid that I'm pointing to, like the ammonium ion, gives away an H+, so we'll end up with CH3NH2 in aqueous solution, and giving away an H+, it'll be H3O+, right? That's an equilibrium though, because there is only a weakly acidic species. It's a weak H+ giver, in contrast to HCl, which is a very strong acid because it's an extremely strong H+ giver. Okay, now that's this one here, because the quaternary ammonium salt CH3NH3Cl dissolves to ionize into these 2 ions, and then it undergoes this hydrolysis reaction. By the way, what is a hydrolysis reaction before anybody asks me? A hydrolysis reaction is an acid or base reaction involving a water molecule. So the water can act as an acid or the water can act as a base. like this one here, where of course the water molecule accepted an H plus, so it's acting as a base. You can have hydrolysis reactions where the water molecule reacts with a strong base and acts as a H plus giver, so it will be acting then as an acid. So the quaternary ammonium salts like these are like ammonium ions, and they dissociate in aqueous solutions to produce a positive ion like this and a negative ion. Then the positive ion, like an ammonium ion, can act as a weak acid in this equilibrium reaction. Okay, any question up to that point? Before I look at the methanamine, CH3NH2, which you know is a weak base. And now we can write the equation for CH3NH2 in aqueous solution. I told you it will dissolve in water because why? There are hydrogens connected to nitrogen, so it can undergo hydrogen bonding interactions with water molecules. Therefore, it will be water soluble. And it reacts with an H2O molecule. This is a weak base, so it will accept H pluses. Of course, it's not a reaction to completion. It's only an equilibrium in which we will end up with some CH3NH3 1 plus, and the H2O gave away the H plus, so it will be OH minus. So here is an example of a hydrolysis reaction in which the water molecule is acting as an acid. Above it, the water molecule, that was also a hydrolysis reaction that I'm pointing to now, but the H2O acted as a base. It accepted H plus. Here it gives away an H plus. That is why we also call H2O an amphiprotic species. It can give away H pluses and it can gain H pluses. An amphiprotic, it can proton donation or proton acceptance. Hence the term amphiprotic. Right, so this sort of thing is like an ammonium ion, a weak acid. This sort of thing here is just like ammonia, weak base. Okay, there. So then, rank the solutions in order of increasing pH. Okay, the most acidic will be the lowest pH. So that will be HCl. So the lowest pH will be HCl. Then after that is the next weak acid here. The next weak acid will be, unlike the strong acid, the weak acid is this species here. So rank the solutions. CH3 NH3Cl, which is a weakly acidic solution, since CH3NH3 1 plus is a weak acid. And of course the CH3NH2 is a weak base, so that will have the highest pH of these three substances here, CH3NH2. The most acidic one has the lowest pH. This is a weak acid, so it will have a higher pH. And this is a weak base, so of these three, that will have the highest in terms of pH. The conductivity of the 1 mole per liter solutions in A are measured. Rank these solutions in order of decreasing conductivity. Compare and contrast the conductivity of each of the solutions with reference to species in the solution. In other words, you need to explain it. Now, to account for that, we need to really look at these solutions here. Look at this reaction. The HCl reacts with that, and they're all 1 molar. So you're dissolving 1 molar concentrations of everything. So that fully ionizes. Electrical conductivity depends on the total number of ions in the solution. Okay, so remember that. Electrical conductivity of a solution depends on the total number of ions in the solution. So this one here ionizes completely, and from 1 mole of the stuff, you'll get 2 moles of ions. That will have the highest conductivity. So the highest conductivity is HCl, and I've explained that to you. HCl, in terms of electrical conductivity now, is the highest. Why? It fully dissociates with each mole of HCl, producing a total of 2 moles of ions. So that's the highest electrical conductivity, which is what we are looking at in part B. Okay. Then, now look at this one here. We have CH3NH3 1 plus, and we have this one here. Now that's a weak acid, and this is a weak base. Okay. Now this one here reacts with water molecules, but most of this quaternary ammonium ion, which I'm pointing to now, right, the CH3NH3 1 plus, stays as is. It stays as is. It's rather like an ammonium ion. Very few of them. It's only a weak acid. So most of it will remain as CH3NH3 1 plus. So you explain this by saying, because CH3NH3 1 plus is only a weak acid, most of the CH3NH3 1 plus stays as is. That's the first thing. There are also Cl minus ions produced when it dissolves. So it produces these ions. So up to now it's a bit like that, like the HCl. The only difference is up to here they are the same. So you'd expect to have the same conductivity. But except for the fact that all the CH3NH3 1 plus doesn't stay like that. Some of it dissociates to become CH3, NH2 and H3O plus. So look at what happens. You get 2 moles of ions here, and some of these ions react with water, but that's not a problem, because for each of these ions that reacts, it produces another ion, H3O 1 plus. Okay? For each ion that reacts here, it produces one there. So the total number of ions in this solution will be the same as that in the HCl solution. So the highest electrical conductivity is the same for both of these things, because the total number of ions in each instance is the same, and I've explained to you why they will be the same. They're equally highest. And understand clearly why. Each HCl produces a total of 2 moles of ions. This one here produces 2 moles of ions as well, but even though some of these, a small number of them, react, through the reaction of each one of them, you produce another ion. So the result is that these two solutions contain the same number of ions. Therefore, they will have the same electrical conductivity and the highest. Now look at this one here, the CH3NH2 molecule. A small number of them, it's a weak base like ammonia solution. It will have weak electrical conductivity. Why? A small number. Why does it conduct at all? Because like ammonia, a small number of these molecules accept H pluses from water molecules to produce this ion and OH minus. But this is an equilibrium. It's not a reaction to completion. It largely favors the left-hand side. So the ion concentrations are very small and it will be the lowest conductivity. So that's CH3NH2, which is the lowest. How beautifully logical and simple this all is. You just need to understand the principles and apply logical thinking.